Force arrows on a crossbow bolt, the answers. Whenever drawing force arrows, I always start with the weight. So the weight is due to gravity on the bolt going downwards. So there's no change in motion, so this force must be balanced by a reaction force caused by a compression of the bolt on the surface of the crossbow. There are no forces going forwards or backwards. As soon as the bolt is fired, we can still draw the weight and the reaction force, as there is no change in the vertical motion, hence these forces are still balanced. But this time there's a large force going forwards, which we could call thrust, caused by the elasticity, the stretching of the crossbow itself. There will be a force going backwards, friction, caused by the surfaces rubbing together. As the bolt loses contact with the string, as before, we can draw the weight and the reaction force, but this time there is no longer a force going forwards. That force has gone. There's no longer a contact, there's no thrust anymore. We still have friction between the bolt and the crossbow itself, and we've also got some air resistance, which we could call drag. As the bolt loses contact with the crossbow, we still have the weight, but this force is no longer balanced by the reaction force, and we know that because the bolt will come down to earth at some point. There's no friction, as it's no longer in contact with the crossbow. There will be a force opposing the motion, which we will call the drag force. Later, as the bolt falls through the air, still going forwards, but it's falling at a constant speed, we know that the weight going downwards must now be balanced by a drag force going upwards, or air resistance. These forces are balanced because the bolt is falling at a constant speed. It is, however, still slowing down, and so there will still be a drag force opposing its motion going backwards, slightly smaller than before, because it's now moving slower than it was before.